Section 4.1 is really discussing quadratic functions, and you're familiar with the quadratic function because you're familiar with the quadratic equation. It has an x squared in it, or a variable squared, and when we graph it, we will always get this bowl shape. Now, the bowl shape can be up like a bowl, or it can be upside down, and those are basically the two types of parabolas that we're going to be working with. There are four basic parts to the parabola that you need to be familiar with. And the first one here is what we're going to call the y-intercept, okay? This point right here is the point where the parabola passes or crosses the y-axis. So you're already familiar with the y-intercept, and that is one of the important points you need to know on the parabola. Another one that you need to know is going to be the x-intercepts, also points that you are familiar with. Usually there are two of those. The only time that there won't be an x-intercept is if the parabola happens to be up here or down here, below or above the x-axis. So here's our second one here. Now, the next thing that we want to know is this point right here, and it's the lowest point on our parabola. It's in the very center. It's the what we would call the minimum point on this one because it's as low as it goes. But this is the vertex of the parabola. This is where it actually stops going down and turns and starts going up. If it was upside down, it would be where it stopped going up and turned and started going down. So this is the very center of the parabola. And the line that goes up and down straight through that vertex is called the axis of symmetry. The axis of symmetry is always going to be represented by x is equal to a number. So just like we would graph a vertical line, x equal, that's what the axis of symmetry's identifier will be. So we're going to work with some of these quadratic functions, and we're going to get familiar with a couple of different formats for the equations to take. The first one is called the standard form of the equation, and that is it has a coefficient multiplied times a binomial squared, which has subtraction as the operation, and then it's plus another number. Now this hk represents the vertex of the let's see, we'll underline it right here for you. The vertex of the parabola. So it will be the opposite. It'll be a positive h if the operation is negative, and it'll be a positive k if this operation is positive. So you just have to keep it in mind. This negative is in the formula, this positive, this plus is in the formula or in the equation already. So it sometimes does have a tendency to change your signs there. Now, so this is our standard form. The form that you're used to is called the non-standard. We would call that the non-standard form of the equation of a parabola. And sometimes it's also called the general form. And it is the one you're familiar with when you're looking at a quadratic. It's ax squared plus bx plus c. And of course, a, b, and c represent the terms, and they represent the different numbers. Now, how would you change it from this non-standard form, or how would you change it from the non-standard form to the standard form? Well, you would simply do completing the square on just one side of the equation, and we'll look at that in just a few minutes. How would you go from the standard form to the non-standard or general form? Well, you would actually distribute this multiplication and then combine like terms. So let's take a look at some steps, and this is a page you're probably going to want to keep handy. How do you determine the sign of a? Well, if a is greater than 0, the parabola is going to open upwards. The vertex is then going to be the minimum point, because if the parabola opens upwards like this, the vertex is at the lowest point. If the parabola opens downward, and now that means that that a is a negative term, then your vertex is a maximum. It is the highest point of the parabola. So we're going to be tasked with finding whether it opens up or down. And then we're going to be asked to find that particular point, the vertex. Then we're going to be asked to find the x-intercept. So when we are looking for that, we basically x-intercept, y is equal to 0, right? Then we'll find the y-intercept. That's where x is going to equal to 0. And we'll sketch it by finding the vertex and connecting it to some of those intercepts. And then we'll be able to identify the axis of symmetry. Now, the axis of symmetry always is the x-coordinate going through this vertex. So if this was a 5, a 5, 2, say, the axis of symmetry would be x is equal to 5. That way we can quickly now identify the domain and range, and those are the 7 things we want to be able to identify with every parabola. So I've got a couple of quadratic equations here, quadratic functions, and we're going to try and find those 7 things about them. One of the things is going to be to graph it on the graph we have on this page. But first, let's start off by asking the first question. Does this quadratic point upwards or downwards? Now, you can see that it is in the standard form. It is a times x plus 2, and it would be actually be x minus h. I'll write it up here for you. Squared, and then the last part of it is plus k. Now, these signs are opposites of what we actually have in the equation. So we're going to find that vertex, we're actually going to have to take the opposite of what we have in the equation, since the signs in our formula are opposite that. So what do we have, though, as far as it points up or down? This 3 right here is positive. So because it has that 3 and it's positive, a is equal to 3, we say it goes up. And therefore, when we get the vertex will be a minimum point. And I'm just going to make a note to myself that the vertex is going to be minimum because the equation, the quadratic, is pointing up. It's opening up. Okay, so what's the second thing they asked us to find out? Was to find that particular vertex. Well, I can see it. It's already in this standard form, isn't it? So HK is the vertex. So this would have been negative. This is a positive 2. So my x-coordinate is going to have to take the opposite sign. This is a positive in the equation or in the standard form. So, but it's a negative here. So it's going to again have to take the opposite sign, isn't it? So I've identified h and k, and they are -2, -4. That is the vertex of my parabola. Number 3, we are supposed to find the x-intercepts. Well, we know that the x-intercepts are where y is equal to 0, and we can always, for g of x, we can always say that's y. So I'm going to say 0 is equal to 3 times x plus 2 squared minus 4, and then I just have to solve for x. So first, I'm going to add 4 to both sides. And then I'm going to divide this by 3. When I divide both sides by 3, I end up with 4/3 over here. And that's equal to x plus 2 squared. Now, to solve this one, I need to take the square root, don't I? So I take the square root of this side, and I have to take the square root of 4/3. Remember, it has to be plus or minus, doesn't it? So now all I have to do is subtract 2 from both sides, and x will equal a -2 plus or minus the square root of 4/3. You can switch it around the other way if you want to see it written the other way. So I have my x-intercepts. My x-intercepts are going to be -2 plus the square root of 4/3, -2 minus the square root of 4/3, and I can do that really easily in my calculator, and I'll say my x-intercepts are going to equal, and I came up with -3.15 and -0.85. Now, they're not the best ones to graph, but they're still possible for me to do a half-decent job of it. Let's go on and see if we can find the next question, which is the y-intercept. Well, this one, of course, we have to have x equal to 0. So I'm going to look at my original equation. I'm going to write y is equal to 3 times 0 plus 2 squared minus 4. So y is going to equal 3 times 2 squared, which is going to be 4, minus 4, which is 12 minus 4, isn't it? And that's 8. And so that is going to be my y-intercept. Is going to be 0, 8, right? All right, Lel wants to know if we can graph it. I'm going to go down here and do number 5 because that was the next one on our list. And I'm going to see if I can graph it based on the vertex. The vertex I found was -2 and then -4. So I'll go -2, -4. I know that's the bottom of it. I know I've got a bowl shape pointing upwards. All I need now is some of these other points. I did find these x-intercepts, -3.15. So I can kind of guess that. There's -3. I'll put -3.15 right about here. And -0.85 is almost to the number 1, right? So it's going to be right about here. And the other thing that'll help me is where's the y-intercept? Well, it was y is equal to 8. So this is the y-intercept. So I can sort of say this is my bowl shape. Kind of is a really narrow and tall bowl, isn't it? And I'm trying my best to draw these lines right, but you get the picture. That's the basic shape of my parabola if I could draw a straight line. And that's good enough for my graphing of this. Most of the time, you'll be looking for whole numbers as intercepts or something so that you can easily graph it. But this suffices. Okay, let's look at number 6 now. For 6, we are supposed to identify the axis of symmetry. Well, now the axis of symmetry is right here. I'm going to just draw it with dotted line. And that axis of symmetry is where x is equal to a number. This one is where x is equal to -2. And that's going to be my axis of symmetry. Okay, number 7 says identify the range in the domain. Well, for all quadratics that are normal quadratics, your range, your domain is going to be all real numbers or negative infinity to positive infinity, and this one is no different there. What about the range? The range says what's the lowest value it can possibly be, and it goes down to a -4. And then it goes all the way up to positive infinity. So I'll just put it, this is my domain, this is my range. Okay, let's take a look at the next one and see how it is a little bit different because it's not in the same format for us. This one is actually in the format of the general equation, which was ax squared plus bx plus c. So we have an a and a b and a c term. And we really can go ahead and identify the facts without taking this thing and putting it in that standard form. If you look back at the previous page, there's some notes on working with this format of the parabola or the quadratic, and it tells us that the x-coordinate is always going to be -b over 2a, which is going to sound familiar because it sounds like that is a little bit like the center of your circle, doesn't it? So let's take that and say, okay, -b, if I want to say the vertex, I'm skipping a part. Let me just go back up and say, what does this one open up or down? And I see that this is a is equal to a 2. So it opens up. So once again, the vertex will be the minimum. Now let's go to what I was trying to get to a minute ago, and let's see if we can find that vertex. The x-coordinate is going to be -b, well, b is 28, so it's -28 divided by 2 times a. And that's not too hard to do. We have -28 divided by 4, which gives us a -7. So I know the vertex, I'll just put it up here, I know the x-coordinate of the vertex. It's going to be a -7. Let's see if we can figure out what the y-coordinate's going to be. How would we figure that out? Well, now we just plug in this -7 for x and we solve for y. So we have y is equal to 2 times -7 squared. And then that's going to be plus 28 times a -7 plus our 80. Okay, and the math is not too difficult with this. Y is therefore equal to, this is going to be 2 times a positive 49. And I can go ahead and say this is going to be minus 196, and that's plus 80. And I find that y is therefore equal to 2 times 49 is 98, minus 196 plus 80, which comes out to be, in my calculator, I would type all that in and say that's a -18. So the y-coordinate is going to be -18, and I have found my vertex. Part number 3 says find the x-intercepts. Well, for the x-intercept, we want y to equal 0. So we can do the same thing that we did. We don't have to have a special format of the equation to do that. We just say y is equal to 2. I'm sorry, y is equal to 0, right? 0 is equal to 2x squared plus 28x plus 80. So I've got 0 is equal to, and I just need to kind of see if I can factor this. That's how we usually solve quadratics, right? I can factor out a 2, and then I have x squared plus 14x plus 40. And now I'm looking at it saying, can I factor this without getting into the quadratic equation, which is a little bit messier for me? I would say this would be an x plus, this would be an x plus factor, and I need factors of 40 that can add to give me 14, and I believe 10 and 4 will do it for me. I double check that by doing FOIL real quick in my head, but yep, that looks right. So I know that this is going to be x is equal to a negative 10 and a negative 4, because that's what would make this equation 0. So these are the x-intercepts, aren't they? Negative 10, negative 4. Now, the next question, of course, is what's the y-intercept? Well, this time I just have to plug in 0 for x. So I'm going to say y is equal to 2 times 0 squared plus 28 times 0 plus 80. Well, this is going to be 0, isn't it? And this is going to be 0. So all I really have is y is equal to 80. And that is my y-intercept. Now, what is the axis of symmetry was a question that we were asked, but the fifth question is graph it. So let's go down here and see if we can graph this. Now, this vertex is not going to be easy for me to graph because it's a negative 7, negative 18, which is not on my graph, but I'm going to do the best I can. 10, and then I would say I'm going to kind of go over here to a negative 7, and I'm going to try and go below that. 1, 2, 3, 4, 5, 6, 7, 8, sort of at the very bottom of my page here is where I ended up. Let's see if I can get your camera to show it. So I ended up way down here at the bottom for this vertex, didn't I? And now I need these x-intercepts, negative 10 and negative 4. Well, negative 10 is right here. Negative 4 is right there. So I'm going to be going up through those. And another thing that'll help me is where's the y-intercept? Well, it's at 80. It's way off the chart, isn't it? So I'm just going to kind of do the best I can with this one. We've done the math. We know what it's supposed to be. It's not going to cross that y-intercept until it goes way up there to where y is equal to 80. But I could easily find the axis of symmetry, right? I can find it by looking at the x-coordinate of the vertex. And the x-coordinate of the vertex is x equals negative 7. So that's the question for 6. Is x is equal to negative 7 is the axis of symmetry. And now we want the domain and the range. So it's pretty simple to identify the domain of this one. It's the standard parabola, all real numbers. So I say negative infinity to positive infinity, and that's the domain. And then for the range of it, I'm going to start at this negative whatever I found. What was it? Negative 18? And it does reach that number and go all the way up to positive infinity. That I will identify as my range. So this gives you an example of working it from the standard form and working it from the non-standard or the general form. You should be able to do both of those. On page 4, I've got 2 more. One is in the standard form and one is in the general or the non-standard form. Let's look at those two. I'm going to once again write the formula up above it of the general form, of the standard form, sorry. And it says A times x minus h squared, you'll just need to memorize this, plus k. The only reason I'm doing that is because I know my vertex is already there, but I need these signs to tell me whether I have to change the sign of the point that's there or not. The first thing I want to do is identify which way does this parabola point, up or down. So I look at A, and A is equal to negative 1. The 1 is understood there. It's pointing in a down direction this time because it's a negative. Therefore, the vertex is the maximum point in this graph. So it's the opposite of what we've been looking at. So down says the vertex is the maximum point. Now, the next thing we're going to look for is what is that vertex? The signs that are in my equation are the same that are in the standard form, aren't they? So I can just take those coordinates and say 1 is x and 9 is y, and that's my vertex. Let's look at number 3. 3 tells us that it wants us to find the x-intercepts. So for x-intercepts for this one, I'm going to set y is equal to 0. I'm going to say 0 is equal to negative x minus 1 squared plus 9. And then I just have to solve for x, don't I? So first I'm going to subtract 9 from both sides. I'll have negative 9 is equal to that negative x minus 1 squared. And then I'm going to divide. I want to get rid of this leading negative. It's the coefficient, isn't it? And I want to get rid of that. Just divide the whole side by negative 1. I divide negative 9 by negative 1, and I get a positive 9. And all I really did on this side was get rid of that negative that was multiplied here. Now I need to take the square root. If I take the square root of this, I get x minus 1. And when I take the square root of 9, I'm going to get 3. But it's going to be plus or minus 3 because I have to take both versions or both sides of that square root. Now I can say, okay, I add 1 to both sides, and x is going to equal this positive 1 plus or minus 3. And there I do have 2 x-intercepts. So my x-intercepts are going to be where x is equal to, let's do the 1 minus 3 first. And it's going to be a negative 2, isn't it? And then the other one is going to be 1 plus 3, or 4. So here are my x-intercepts. X-intercepts. So negative 2 and positive 4. Now let's go ahead and do the y-intercept. For the y-intercept, we just want to look at what y is if x is equal to 0. So we'll plug in 0 for x, and then we'll solve for y. Now this is going to be a negative 1 squared, isn't it? Negative 1 squared is just 1, but then I have a negative out front. So it becomes a negative 1 again. Plus 9 is going to give me, it's like 9 minus 1, I'm going to get 8. And that is my y-intercept. Y-intercept is y is equal to 8. So let's see if we can graph this one. We'll go down here and do our graph. This is the question number 5 that's on your chart on page 2. And the first thing I do is find the vertex. It's at 1, 9. There's my vertex. The next thing I do is see if I can identify where these x-intercepts are. They're at x is negative 2 is one of them, and x is 4 is the other one. Then the y-intercept was where y was equal to 8. This makes it pretty straightforward to graph it. It goes through both those intercepts. It goes through the y-intercept. It turns at the vertex and goes back down. It would be exactly split in half. If I had drawn it correctly, it would be, each side would be exactly the same if we folded it on this axis of symmetry. And that axis of symmetry, of course, is x is equal to a positive 1. So I've identified the next thing that it's asking me. What is the axis of symmetry? And I'll say the axis of symmetry is where x is equal to 1. Now, the last question, domain. Typical domain for a quadratic, it's going to be all the way to the left and all the way to the right. And that's my domain. My range, it's going to be the smallest it ever gets is negative infinity. The biggest it ever gets, it's going to stop right here where y is equal to 9. And it does reach that point. So that's how I identify my range. Question number 4, the next one we have is one that's in the non-standard or the general form. So I'm going to work with it like that. And I'm going to write that form of the equation above it, just so you can see it. That's what it is. And the first question, of course, is this parabola pointing up or down? Well, I identify what A is equal to, and if A is positive, and it is, then it is pointing up. So, therefore, the vertex is the minimum point, the smallest point on my graph. Now, the second question is, what is that vertex? And I'm just going to write out here, this is the vertex, my place for it. The first thing I have to do is say it's in this non-standard form. So I'm going to say x is going to equal, and I call it negative b, which is negative 12, over 2 times a, which is 2 times 2. Well, that's negative 12 divided by 4, which is -3. That's 1 point of my vertex, x value of -3. Now I'm going to plug in -3 for for x, and see what y is. So it'll be 2 times -3 squared plus 12 times -3 plus 10. And I just do the math. -3 squared, of course, is 9. So that's going to give me 2 times 9, which is 18. And 12 times -3 is -36. And then I have just plus 10. So 18 minus 36, that's a -18 plus 10. It looks like I've got a -8. And of course, your calculator will tell you for sure if you've got this right. But that's my y coordinate of the vertex. So I've identified my vertex as -3, -8. Now I need the intercepts. So let's take a look at what the x-intercepts are. We need y to be 0 for this one. So I'm going to say 0 is equal to 2x squared plus 12x plus 10. And it looks like a typical trinomial that I can factor. First, I'll factor out the GCF. 2 times x squared plus 6x plus 5. And I'm hoping that it'll factor without going into the quadratic formula. The bottom line is really that you should always try to factor the quadratic equation before you go to something like the formula. This one is going to factor pretty easily for us. We're going to say x plus, and we say 5 factors into 5 times 1, and of course 5 plus 1 gives us 6. So we can see that our x-intercepts are set for us, pretty obvious. They will be x equal to a -5 and a -1. Next is question number 4, which says look for the y-intercept. Well, of course, for the y-intercept, we need x to be 0. So we come back and change our equation. We say 2 times 0 squared plus 12 times 0 plus 10. Well, of course, this is going to be 0 times 2, which is going to be just 0. This is 12 times 0, which is 0. So all we have here is 10. Our y-intercept, therefore, is y is equal to 10. Now, let's go down here and graph it since we have those pieces in place. And I find my vertex first. It's -3, and then I go -8. Right here would be -3, -8. I'm going to find the x-intercepts. Those x-intercepts, of course, are going to be where x is equal to, I say they were, let's see if I can find them again, -5 and -1. So -1 and -5 will be my x-intercepts. And my last piece is my y-intercept is equal to 10. And now I have my correct, and I know it's pointing up, and so everything looks right on my graph. I'm just going to see if I can draw it as evenly as possible. Of course, it would split right around the axis of symmetry, which is here, going through the vertex. And that axis of symmetry is where x is equal to a -3. That was question number 6. So I'll say the axis of symmetry is x equals -3. Finally, what is the domain of this one? Well, it's a typical quadratic equation, a quadratic function that goes from -infinity to +infinity. And the range of it, I have to look at the low point. It goes all the way down to a -8, and it does include that point, and it goes all the way up to +infinity. On page number 5, I've given you a really quick overview, just notes at the top so you can see exactly what we're talking about when we say it opens upward, opens downward, and where the axis of symmetry is. When a parabola opens upward, of course, the vertex is the minimum value. When it opens downward, the vertex is the maximum value. Now, also over here are just some really quick notes on how to find that vertex if you're in the standard form, the general form. And let's take a look down here at a few questions. We're going to see, without graphing it, whether a function has a minimum or maximum value. And all we're really asking is, does it open upwards or downwards? And then we're going to find the minimum and maximum value. We're going to find the vertex, right? And then we're going to find the domain and range. And we can do that quickly without having to graph the parabola. This one is already in our standard form, so I'm going to write it down here. It's a times x minus h squared plus k. And I know the vertex is hk, and this is the correct format, so I'm just going to answer my first question here. Question A, is it a minimum value or maximum value that this one has? Well, a is equal to 1. Therefore, it's positive. Therefore, this one opens upward, doesn't it? So I would say the vertex is therefore a minimum value. If it opens upward, see, you've got the minimum value. The vertex will be at the bottom, won't it? B, what is that value? In other words, what is this vertex? Well, I can see it, and this one is really easy because I've got h and k as the vertex. The signs are correct in my equation here. They're the same as they are in the formula. So I'm just going to say my vertex is 1, 2. And the location, if they ask me that, the location is always going to be what is the x value, okay? The location of the vertex or the minimum value is x is equal to 1. The value of that minimum value is the y. Y is equal to 2. So those are the two terms you need to get used to for the vertex. Is the location is the x, the value is the y. C, what's their domain? Well, this is a typical parabola opening up. Domain is going to be negative infinity to positive infinity. And then I have to think about the range a little bit. It does have a minimum value, so that vertex is going to be at the very bottom, and I'll say that is where y is equal to 2. And then it goes all the way up and opens up at the top, so it goes all the way to positive infinity. And that would be the questions that they want answered without having to graph it. Let's see if we can do one that's not in that general form. Let's see if we can do one that's not in the standard form, rather, but in the non-standard or general form. And for this one, I think about it like this. I think it's ax squared plus bx minus c. Now, I want to identify, first of all, does it have a minimum value or maximum value? So I have to know, does it open up or down? And I look for a, and a, of course, is a -1 here. So that tells me that this is going to open downward, and therefore that vertex is going to be the maximum value. It will be at the top of my curve. The second question is, where is that vertex? In other words, let's talk about the location and the value of that maximum value. So I have to find it first. And for this one, I'm going to go back to my old technique. I'm going to say, well, it's x is equal to negative b, which will be a -4, divided by 2 times a, which is 2 times -1. So I've got -4 divided by -2, don't I? And that would basically be a -2. I'm sorry, +2. So I've got an x is equal to 2. And let's see what y is equal to. When I put an x value of 2 in here, I'm going to find y is equal to 2 minus 1 squared plus 2. And 2 minus 1 is, of course, just 1. So that's 1 squared, which is 1, plus 2, well, that's just 3. So here is my vertex. It's going to have 2, 3 is the vertex. It's going to have a location of x is equal to 2. And it's going to have a value, if you're asked that question, of y is equal to 3. Now, domain and range. The domain for this one, typical parabola that opens down, is going to go from negative infinity to positive infinity. There are no restrictions on it. And the range here, I have to look at it and say, well, it has a maximum value, so it's going to stop, isn't it? It's going to stop up at the top, but it'll go all the way down to negative infinity. However, it stops at that y value, doesn't it, of 3. That's the tip top of it. Let's see if we can do one more. This one is, again, in the format of ax squared plus bx plus c. And I want to answer the question, does it have a minimum or a maximum value? So I'm looking to see what a is, and a is equal to a -3. So that tells me it's going to open down because a is negative. And that tells me it's going to have a maximum value. Now let's find that value. In other words, let's find the vertex of it. Once again, we've got this non-standard form, or the general form. So I'm going to say I've got x equal to negative b, which is a negative 12, isn't it? So I've got 12 divided by 2 times a, which is 2 times a negative 3. And that's equal to, of course, 12 divided by negative 6, which is equal to negative 2. So that's the x value of the vertex. And we'll plug that negative 2 in and say y is equal to negative 3 times negative 2 squared minus 12 times negative 2 minus 17. When I do all this math, I'm going to come up with negative 2 squared is 4, right? And 4, positive 4 times negative 3 is going to give me a negative 12. I'm going to say this is negative 12 times 2, times negative 2, which is going to be a positive 24. And then I have over here minus 17. And I can quickly add those three numbers together, and I will get a negative 5 for y. So my vertex, I'll just make a note here, my vertex is going to be negative 2, negative 5. That tells me that my location is going to be x is equal to a negative 2. And the value of that maximum value is where y is equal to a negative 5. Now, what's the domain and range? The domain is negative infinity to positive infinity. Again, all real numbers would work. And for the range here, I'm going to say, well, it has a maximum value, so it stops at the top. Down at the bottom, it goes down as low as it goes, but I have to stop with a value of negative 5. Now let's see if we can do, on page 6, just a little more graphing with just the information that they've given us. For function, we'll call it this one a. The vertex is a negative 9, negative 3, and this parabola opens downward. All they want to do is see if you can graph that correctly, but I'm going to go, it doesn't give us any intercepts or everything, but when we go negative 5 and negative 9 and negative 3, you can see, and we're going to go downward, you can see we don't have any x-intercepts for this one, do we? Eventually we would have a y-intercept. I'll put this one as a. And let's look at another one. This one says it has a maximum at negative 5, and that's where x is equal to 10. So what I could really think is y is equal to a negative 5 and x is equal to 10. They gave me the vertex, didn't they? So I'm going to say maximum of negative 5. Well, the maximum is going to be right here. Y is equal to negative 5. And it's going to be where x is equal to positive 10. And that's right here. It said it was a maximum value. So I know that this one also has to open downward, doesn't it? Another one that really doesn't have x-intercepts, does it? Because it opens downward past the x-axis. Now for this next one, I want to make a change. I want to change these numbers just to make our math a little easier today to negative 6, positive 5 for the point that's in the function, a quadratic with the vertex of negative 6, 5. And then passing through this point, I'm going to go 154. I believe will be a better point for us. And then when written in standard form, of course, they want us to write it. Now, they've given us the vertex, and they've said it passes through, it goes through, it's got, of course, this vertex, but it's passing through a point. Now, this is not an intercept point. This is just a point that it passes through. And they want to see if we can write this equation in standard form, okay? So what we have to think about is what's it going to look like? I'm going to say, well, it's f of x is equal to a times, and then I've got x, and it would normally be x minus h, right? Well, this is a negative 6, so it's going to be x plus 6, isn't it? Squared. And then it would be plus 5, and that's a positive 5, so that stays the same. So I've inserted h and k. I've inserted the vertex into my standard form of the parabola into where h and k are. That's the first step. Now, the next thing I need to know is what is A? And it doesn't really tell me much about it except for that it's going to go through this particular point. So I'm going to insert the coordinates of the point into y and x and solve for a. Because right now I have three unknowns. I have y equals a times x plus 6 squared plus 5. So I've got three unknowns. And if I can put 1 and 54 in there, then I can pretty easily solve this. So here I go. Where y is, I'm going to put 54. I don't know a, that's what I'm trying to figure out, but I'm going to put in 1 for x, because it does pass through that particular point, doesn't it? And then it's just a matter of solving for a. First, I will get rid of this 5. I'll subtract 5 from both sides, won't I? And I can, at the same time, I can say, well, this is really a times what? 7 squared? Subtract 5. 54 minus 5 gives me 49. And then I'm going to say this is really 49 is equal to a times 49, or 49a is the way we would think about it. Divide both sides by 49, and I have a is equal to 1. So what does my equation look like when it's written in that standard form? It would be f of x is equal to, and you could put a 1 here for a, or you don't have to put a 1 here for a. It doesn't matter, but it would be x plus 6 squared plus 5. All I had to do was find a. I already had the rest of my equation figured out. Now, what about an equation that's in the standard form of the parabola? It has the same shape as this one. Well, it has the same shape as this one. The graph is 5x squared, but it has 1/8 as a point this time. So I'm going to think about this as the format that I need. It's f of x is equal to a times x minus h squared plus k. And I do have something that I know about it, don't I? I have the vertex. So I know I've got a vertex of 1, 8, and I can just plug that in first. So I'm going to say that's a vertex of 1, 8. Now, once again, all I have to do is find a, but they've told me something else. They've told me it has the same shape as this graph. Now, this graph, the coordinate, the coefficient of the x squared term is really basically determining the shape of it, isn't it? Because we remember that's where it compresses or stretches our graph, isn't it? So I can just insert a, 5 for a, and I should have the same shape. And there's my new graph, or my new standard form of this new parabola. Now, quite often when we're teaching students algebra, we hear, what use is this? When do I ever use this? But parabolas and functions of parabolas to find minimum and maximum values are used all the time. Let's take a look at this one. This is a word problem that says Caleb wants to build a rectangular pen for farm animals. One side of the pen is going to be against a barn, so we don't need a fence on that side. The other 3 sides do require a fence, and Caleb only has 800 feet of fencing material. We want the dimensions that maximize the area of the pen. Now, I wanted a little more room to work, so I'm working this one on paper for you. And I've drawn off a rough sketch of what I pictured, the barn, and of course with the pen taking up 3 sides, and this is the fence that Caleb has. And I'm going to write down what I know about it. I know that the maximum area is what I want, and I know that area is always going to equal length times width. Well, I'm going to call these sides here x, and I'm going to call this one y, just because I'm used to working in x's and y's. So I would say the area of that pen would be x times y. Now, what would the perimeter of this pen be? Well, it's only got 3 sides, right? So that's going to be how much fencing he has. He has 800 feet. And if I take the x's and add them together, and I take the length of y and add it together, I have to equal 800 feet. 800 feet of fence, right? Because that's how much fence he has. All right, now I can say, well, that's really 2x, isn't it? Plus y, and I know that's going to equal 800. And then I can say, well, okay, if I solved for y, I could come up here and say y is really equal to a negative 2x plus 800, right? I just kind of solved it for y, didn't I? Now, what is the area of this fence? Well, look, I know what y is. I know the area has to be x times y. What if I came up here and said area is going to equal to x times y, which is negative 2x plus 800, right? Now let's go ahead and solve that, or go ahead and distribute that. We would have a negative 2x squared plus 800x. And couldn't you look at that as a function of x? And doesn't it look like a parabola now to you? Doesn't it look like it's beginning to be a quadratic? So this is what we would call a quadratic, right? And it has a maximum vertex. A maximum vertex. So that's what we want. We want to find the maximum area, don't we? So it's kind of nice that we can do it with this parabola that has a maximum value. And all we have to do is find the x and the y values for them. Now, let's see. How do I find the x value of the vertex? Well, x is going to equal, I would say it's going to be negative b. Well, b is 800, right? Negative 800 divided by 2 times a, which is a negative 2. So that's really negative 800 divided by negative 4, which is actually going to be 200, isn't it? Well, that tells me a lot. If I know that these sides are 200, then I can easily find out what the third side of my fence is, right? Because I can plug it back in and say, now I know y is equal to that. I'll just work it here with this one, negative 2 times the x value of 200 plus 800, right? And that's going to give me a y value of equal to negative 400 plus 800, which is going to equal 400. So this side of the fence is going to be 400 feet. This is going to be 200, and this one will be 200 again, and that will maximize the area of the pin. I know because I found it at the vertex of a quadratic that had a maximum vertex. How do you get the area now? They asked me, what would the area be? Well, of course, the area is easy. We say 200 x times y, right? Or it's going to be length times width to get the area of a rectangle. So I'm going to say 200 times 400. And I'll find out that my area is going to be 80,000 square feet. For the second example, we're going to use a NASA launching a rocket, and the time is going to be represented by t, and then we're going to look at the output as a function of that time. It's going to be the height of the rocket. That's going to be s of t. The output in height is above sea level, and of course, as a function of time, it will be shown in this equation, which is a quadratic. So its s of t is equal to negative 4.9 t squared plus 298t plus 171. Now, this is a difficult one to do any of the math by hand, so I would suggest using your graphing calculator to do this, and I'm going to show you how it works on a TI-84. And we'll use that position function and answer some questions. They want to see when the rocket is going to splash down into the ocean, what time does splashdown occur. They want to know how long does it take it to reach its maximum height, and how high is that height? Now, when you think about it, like we have been thinking about parabolas, if I look at it like this, the rocket goes up, it reaches its maximum height, and then it comes and splashes down. This is going to be the vertex, isn't it? It's going to be a maximum height, a vertex that's going to have a max on this one. So it's going to be the max height. And it's going to equal, the output, right? It's going to be the height is equal to output. So I could say that's equal y is equal to the output. I think about y is the output, x is the input. And it's a function of time, which is my x variable, my input, right? So I'm just kind of jotting that down for you. Now, I'm going to say this over here is my launch. And t, of course, at launch is going to equal 0. T is going to equal 0. And at splashdown will be over here. And I really don't know what time is going to equal. That was one of the questions, wasn't it? So let's see if I can look at what it looks like as far as the height of this rocket. So I say S of t, which is the equation they gave me, is equal to a negative 4.9 t squared plus 298 t plus 171. And I'll say that is height as a function of time. How high does it get in the time that it's given? So let's look at what this vertex is. The vertex of this one is going to be kind of easy. The x value for the vertex, I'll just write it down here so we know what we're doing. This x value for the vertex is going to equal a negative b, negative 298, divided by 2 times a negative 4.9. And when I do that in my calculator, I get 30.41. So I know that this one is going to be an x value of 30.41, which is the time, right? That's the time. That's the x value, that's the time. So now I need to know, well, how high is that? So I'd need to calculate the y. Now, you can calculate y with this. You can go down here and say y is equal to, and I'll plug in negative 4.9, I'll plug in 30.41 every time I have t, right? Because that was the time. And I say squared plus 298 times 30.41 plus 171, and I come up with 4701.82. Sure, you can do that math in your calculator, right? So what is that? Well, that's going to be the height. It's going to be 4701.82. Of course, it's the maximum it will reach, time and height. I'm sorry, with this time, it will give us that height. So, the splashdown and the launch are sort of like, we would think of sort of like, x-intercepts down here maybe. And I can look at this in the quadratic form and I can sort of calculate and find out my x-intercepts, or I might want to do it a different way, assuming that I can use my graphing calculator for it. Let's first, though, look at how we would get this quadratic form of the equation and come up with what these values for t, or maybe we'll call them x, would be. I have my equation written, don't I, in the form of a times x squared, if I think about it like that, plus b times x plus c. So, I'm sorry, plus c. So I really have the quadratic equation, and I can solve for what's the unknown. This one, well, it's going to be t, isn't it? So I'm going to say this is equal to negative 298, which would be negative b, plus or minus the square root of 298 squared minus 4 times a times c. And all of this is divided by 2 times a. So you can do this math just about any way you want to, and sometimes I choose to, because I'm going to have to do it twice with the plus or minus, I choose to do this, say negative 298 plus or minus, and then I come up with what's under the radical. I went ahead and simplified that and got 92155.6. And I say all this is going to be divided by 2 times negative 4.9, which is a negative 9.8. And then I went back to my calculator there. And let me just get some things cleared up here. And I said, hang on, I think you can see better when the light is on. There you go. I think that's better. So I entered this in. I said negative 298. And I said plus first. I went plus the square root of 92155.6. And I just did, and that's just the numerator, and I just went ahead and did that one. Negative 298 plus that radical. And then I said divided by a negative 9.8. which gave me a negative 0.57 if I round it to 2 decimal places. So I'm looking at one of my answers as being a negative 0.57, and I know that this is time, so I'm thinking, well, that one's not going to work. So I can sort of dismiss that one. Let's see what the other one comes out to be. So I type it in. I've got the same equation up here, and I just want to use it. I just want to put minus instead of plus. So I'm just going to highlight it, press enter, and it copies it down for me so that I can just run back over here with my arrows and change that to a minus instead of a plus, and then I can hit enter again. And this time it gives me negative 601.57, and I can take and divide that by negative 9.8. And I get 61.38. So 61.38 sounds like a good time to me, and that is going to be the time of splashdown. How many seconds after launch did we splash down? We didn't really have any use for the negative side of this, but we did have use for the positive side. So we say, okay, that's 61.38 seconds. Now, so we've answered all of our questions on our piece of paper, but I want to go in here and show you one more thing that you can do with your graphing calculator. First, you can enter this into your y equals, and it's not an easy function to enter in, but it's negative 4.9 x squared plus 298x plus 171, and then graphing it is a bit of a problem unless you have adjusted your window. Now, to adjust the window for something like a rocket launch, you've got to consider that that rocket's going to go really high. In other words, I gave it a y maximum of 5,000 and a minimum of 10, and I said increments of 100. I really want to give room for it to go way high. And x's, I played around with those. I came out with negative 10, maximum of 100, and I set a scale of 20. And you can play with those numbers and make it so that your graph looks, reasonable to you. And then when I graph it with that window, this is what I've got. Now, I want to be able to tell what that, say I haven't done the calculations, I want to be able to tell what that vertex, that maximum vertex is. So I can go to something called second and calc, and I can say, I want you to calculate the maximum for me. So I'm going to hit maximum there. And it puts the cursor somewhere on the graph. I'm going to use these little arrows to kind of move my cursor, because the first question it's asking me, down here it says left bound question. So it wants me to put my cursor to the left of the point I'm interested in. So I put it to the left of the vertex, just a little to the left, and I hit enter. And it draws a line. And now it says right bound. So it wants me to go to the right of the vertex. And I did. And I hit enter. And now it says, do you want me to guess? Well, I'm going to go and tell you, yeah, I want you to guess at the maximum point between those two. So I put my cursor back between those two. And I hit enter again. And it gives me a value, what it considers the value that it is the one I'm looking for. It tells me that that x value is 30.408 or 30.41, which is what I found the x value of my vertex to be. And so that's the way that you can get the maximum value of your vertex. Where is it on the x-axis? What's its location? You can find it if you want to by using that second and calc. You're trying the calc. It's right under the trace button. You're going to go second and calc, and you're going to look down for max value once you've already gotten your graph set up in your table. Okay, let's see what answers this has given us, because I think we have everything we want to answer our questions. And it says, assuming the rocket will splash down into the ocean, at what time does splashdown occur? We found it would occur at 61.38 seconds after it launched. And when does it reach its peak height? Well, we found out that its peak height was going to be 30.41 seconds after launch. And how high does it get? Well, we found that to be 4701.82, and it was in meters. Now you can see by using this how useful the parabola is, and the function of a quadratic is really, really valuable in space travel and in things that we're calculating, like if we want maximum and minimum values, this becomes a very useful tool.